All right, welcome back, Hononegah. Algebra 1. Today we're going to do the last form. So we've done standard form, and we have done vertex form. And so now we're going to do the last form, which is called intercept form. And so when the quadratic, it looks like this. So basically when it's in factored form, okay, when it's been factored out completely, that's really basically putting it in intercept form. And so in intercept form, this allows me to come up with where the x-intercepts would be located, because that also then tells me where the zeros of the function would occur. So you already have graph quadratic functions written in several different forms. So they were standard form and vertex form. So today we're going to talk about, again, intercept form. When it is in this form, the P and the Q are the x-intercepts. So that gives you 2 points. And then all you have to do is find the halfway point between, because remember, parabolas are symmetrical. So the halfway point, or the midpoint between the x's, and that's where the x-intercept would occur, and when the axis of symmetry would occur, and then all you have to do is plug that net value back in to find the vertex. So here we go. Describe the domain, the range, label the vertex, the axis symmetry, and the x-intercept. So x plus 1. Find out where that equals 0, and that is one of the x-intercepts. Find out the solution. Whoops, that's a positive 5, 0. So those give me 2 points. Now, in order to find the actual vertex then, you find the midpoint, or the midway value, between the two x-intercepts. So we're talking about x equaling 2. That's the axis of symmetry. And if I plug 2 back into the function, so now 2 plus 1 would be 3. 2 minus 5 would be negative 3. I get positive 9. Because there was a negative out in front. And so that's all you need. You only need those 3 points when graphing something in intercept form. Now, domain. Domain would still be all real numbers, so that hasn't changed throughout all of them. And the range, just like all the other ones, you're going y is either less than or equal to, or greater than or equal to. So in this case, because the parabola goes down, it's less than or equal to the y value of the vertex. So those are answering all the questions there and graphing. So let's do some more. Now, if I want to put something in intercept form, basically all I would have to do is factor it. So I'm going to take so if I ever want to put something in intercept form, that's really all you have to do is factor it. So when we're talking about intercept form, we're talking about a factored form. So now x equals 2, which means 2, 0 is an x-intercept. X equals negative 2, so negative 2, 0 is an x-intercept. So negative 2, 0. Now, the halfway point between those two would be at 0. And if I plug 0 in, I get negative 8. So there's the graph version. X equals 0 is the axis of symmetry. There's the vertex. The x-intercepts. And so now the only thing I have left to talk about is domain and range. The domain would be all real numbers. And the range would be y is greater than or equal to negative 8. You try this one all by yourself. So go ahead and hit pause. All right, welcome back. So I got negative 2, 0, positive 3, 0, which actually isn't going to be very nice here. Negative 2, 0, 3, 0. And so the halfway point between those two is when x is a half. So if I added 3 and negative 2 together, I get 1. Divided by 2 would be a half. So if I plug a half back in, or 0.5 back in, I get halves. And then this would be negative 5 halves. So I get negative 25 fourths. Or if you had negative 6.25. So there's the graph. So we found the intercepts, we found the axis symmetry, we found the vertex. So domain is all real numbers, and the range is y is greater than or equal to. And if you wrote negative 6.25 or negative 25 fourths. I'm going to go ahead and factor this. So I'm going to go ahead and put it in intercept form. So I've got 3, 0 and negative 3, 0. Halfway point between those two would be x equaling 0. So halfway. Plug 0 back in, you get negative 36. Well, that isn't very nice. So you're going to talk about something that was way off the graph. Domain would be then all real numbers. And the range is y is greater than or equal to negative 36. In section A2, you learned the 0 of a function is the value that with f of x is 0. You could use the intercept form of the function to find zeros of the function. So this is kind of just doing what I just talked about. If it's an intercept form, when I set this equal to 0, I get x equals 1 and x equals negative 2. So find the zeros of this function. This is getting back into your factoring skills again. If there's a GCF, I should take that out. And so this is all going back to those of you that struggled on your factoring. Set the parentheses equal to 0. Set the parentheses equal to 0. And find the zeros of the function. This was almost in factored form. This is the difference of squares. And so the zeros are when x equals 1, x equals 4, and x equals negative 4. So finding the zeros when something is in intercept form. So now use the zeros of the graph. So everything about today is all about having something in factored form. So they prefer everything to be in factored form so that I can actually graph this. So x equals 3 and x equals negative 1. So 3, 0, negative 1, 0. So I've already answered the question, to be honest with you, is that x equals 3 and x equals negative 1 would be the 0. Actual finish the graph here. The halfway point between these two is at 1, negative 4. So there's the vertex. The axis symmetry would be x equals 1. Again, these are all questions that we've answered in the past. So that would conclude today. This is something we'll do in class then. And so if you have any questions, please make sure you talk to your teacher. Not sure what the assignment will be for section 8.5. I believe it is a worksheet. I'm going to go all the way back to the front. It is 8.5 day 1 worksheet. If you have any questions, please make sure you talk to your teacher, and good luck.